Yeah.
Hi, Izuke. Hi, everybody. Thank you for the nice introduction, and sorry for not being able to... Can you hear me?
Yes. Yes.
Okay. Yeah, sorry for not being able to talk to you from face to face, but I'm kept here due to important internal issues. Is my presentation on the screen?
Yeah. Yes.
Okay. I slightly modified the title of the presentation, and today I'm going to talk about the current development of a global water quality indicator in support of the Sustainable Development Goals, and about the monitoring requirements that relate to the development and the calculation of such an water quality indicator. Could you go to the next slide?
Okay, which
introduction.
One? Okay, introduction.
Yeah. Okay. I assume that you already talked about the Sustainable Development Goals and the Goal 6 on water, so I don't go into too much depth here. But at the moment, we have the proposal for that goal number 6 with 6 sub-targets, one of them being target 6, covering water quality and the improvement of water quality by reducing pollution. In that context, based on the experiences from these Millennium Development Goals, a number of UN agencies have formed an initiative aiming at integrating monitoring of water and sanitation-related SDG targets back in 2013, realizing that the water sector at the moment does not have an integrated and coherent monitoring framework to support the member states and the international community in measuring progress towards the SDGs on sustainable water and sanitation. Back in 2013, and supported by the Swiss Development Corporation, a number of UN water members, namely UN Habitat, UNEP, and WHO, formed that initiative. And could you go to the next slide?
Yeah, I'm here.
And initiated a process to prepare the development of a coherent water monitoring framework. In the first phase last year, expert task teams were formed to develop and assess existing indicators and develop appropriate indicators for each of the 6 SDG Goal 6 targets. And I don't want to go too much into detail here. The result in terms of water quality of that task team was to base the future development of the water quality indicator for ambient water quality on an existing indicator that has been developed through the GEMS water program in the past. As a result, UN Water proposed 2 core indicators as a result of the task team and collaboration process in 2014. UN Water proposed 2 core indicators for water quality in general, one covering wastewater, and that is the percentage of wastewater safely treated. And the one relevant to our talk today, to my talk, is the second core indicator. This is the percentage of receiving water bodies with ambient water quality not presenting risk to environment or human health. Could you go to the next slide, please?
Okay.
So before I further dive into the development of the water quality indicator, or what has been developed up to today, I'll first give you a short introduction about the GEMS water program and the related data. So on that slide, you see the current structure of the GEMS water program, which has been has gone through a major transition process recently. The program was run and operated by the government of Canada for more than 30 years, since 1978 until last year. And now the entire program is restructured with 3 main components. One under the central governance of the United Nations Environmental Program, and 2 global centers, one covering capacity development that is currently being established in Ireland, and the other one being the GEMS Water Data Center that has been established at the Federal Institute of Hydrology last year, and that I'm coordinating. And we here focus on the data collection of water quality monitoring data from national monitoring networks and also research monitoring networks. That entire global structure is then supported by, on the one hand, partners in the countries that operate national water quality monitoring networks, regional offices of UNEP and other UN agencies, and regional hubs. And these regional hubs, by the way, Marcelo, who's guiding the session, is head of the first regional hub that we established in Brazil. And these regional hubs are supposed to support the program in terms of outreach, capacity development, and communication within the regions. Next slide, please.
Okay.
GEMS Water, and specifically our center here in Koblenz, continues to maintain and extend the largest global water quality database and information system, which is called GEMStat. And on the picture, you see the global distribution of monitoring stations by station type in terms of the water body being monitored. And currently, the GEMS Water data repository covers rivers, lakes, reservoirs, groundwater, and wetlands, with more than 4,100 stations in more than 130 countries worldwide, comprising about 4.8 million sampling values for more than 250 water quality parameters, covering a range of from 1965 to 2014. Next slide, please.
Okay.
So now I'll dive a little bit into the development of the water quality indicator. The basis for the indicator, for the development of the upcoming SDG ambient water quality indicator, is the GEMS Water Global Water Quality Indicator that has been developed in support of the Environmental Performance Index that was established in 2008. The aim of that water quality index is to assess the overall quality of inland surface water resources relating to aquatic ecosystem health. And the index itself is a so-called proximity to target index that compares measured values at the station level in the first place with, of certain water quality parameters with a benchmark or a guideline value. Next slide, please. The index is calculated as follows. So in the first step, the data is pre-processed and erroneous records such as non-detect and so on are removed to ensure a certain data quality. And the second step, yearly averages for each station and each selected parameter are calculated from the pre-processed data. And then in a second step, for all those stations that have at least 3 measurements per year per parameter, the 5-year averages are being calculated. So there's a temporal averaging process being in the second step. It is important to note here that the 5 last yearly averages are used for that 5-year averages. In the first step, the so-called proximity to target scores are being calculated, and the score is being calculated as the difference between the 5-year average for each water quality parameter and the defined target, divided by the range between the minimum or maximum of the measured parameter concentration and the target. For those stations where required data is sometimes not available, empiric polynomial regressions have been established, for example, to calculate total phosphorus and total nitrogen. In a next step, the proximity to target scores are scaled to a range between 0 and 100, where 100 indicates that the target for each parameter is met. And the further you go away from 100, the larger is the discrepancy towards the target. It is the lower the quality of the water. In the fourth step, then these station level proximity to target values are averaged per station to finally calculate the global water quality indicator at station level. And in the last step, the indicator is calculated at the country level by arithmetically averaging over the station level indicators. In order to, or assuming that a denser monitoring network offers a more detailed and robust information about the water quality in a country, the country-level water quality index is finally being adjusted for the density of the monitoring network, referred to the populated area in a country. So the indicator, the final resulting indicator, might be reduced up to 80% of the original value. Next slide, please.
Okay.
So for the selection of the relevant guideline to determine the targets for the indicator calculation and the parameter selection, for the guideline selection, due to a lack of relevant ambient water quality guidelines, ecosystem guidelines, the WHO drinking water guidelines have been used as target values for the selected parameters. And due to limited data coverage, 5 main water quality parameters have been selected to cover a broad range of relevant water quality impairment, such as oxygen depletion, nutrient pollution, acidification, and salinization. And these parameters, as you can see in the left column of the table, are dissolved oxygen, pH, electrical conductivity, total nitrogen, and total phosphorus. And in the second column, you see the target values taken from the WHO guidelines with respect to these parameters. And the remaining columns denote the upper and lower bounds and the score range between these bounds. Next slide, please. So far, we are currently working on assessing the feasibility of that index with respect to a use for the Sustainable Development Goal reporting and monitoring and reporting. And what you see here on that map is a preliminary assessment of the data available in GEMStat at the moment that is necessary to calculate the global water quality index. And here you see that actually only 19 countries, the ones marked in blue, have recent data available so that you can actually calculate a contemporary global water quality index. So there's a large gap in the required water quality monitoring data availability at the moment. This situation can be improved. Currently, we are migrating the entire system, so for the next couple of months, plan to import a lot more information from those countries that make their data available freely and online. But for many countries, especially in Africa and Central Asia, we either lack the context to national water quality monitoring networks, or they do not report for any reasons, or there is none at all. So that situation remains to be problematic in many parts. Next slide, please. Apart from the data availability issues, there are also some methodological issues with respect to the usability within the SDG context. One is the spatial scope. So the current indicator, the proposed indicator, only covers surface waters, which is problematic in semi-arid and arid areas where groundwater is the most important water resource. A second issue is the temporal scope. Currently, the indicator uses per country different time ranges just based on the data availability. So there's a lack of comparability of the calculated targets among the countries, which is problematic as well. Another issue is the thematic scope. So the developed indicator only focuses on aquatic ecosystem health and does not include the required human health aspects. as stated in the proposed indicators. So the inclusion of health-relevant water quality impairments will be necessary. Another issue at the moment is the choice of guidelines. We, for the time being, use the WHO drinking water guidelines, but are looking actually at source waters. And at the moment, there's just a lack of existing water quality guidelines for aquatic ecosystems. Furthermore, in order to assess actually the percentage of receiving water bodies not to pose a risk to human health and aquatic ecosystems, we need additional, we lack actually hydrographic metadata with regards to rivers and lakes at the moment. So this brings me to my conclusions. Next slide, please.
Oh, this is the end. Oh, sorry. Oh, I find this. Okay, sorry.
It should read
it's a conclusion. Yeah, I find it.
Yeah, okay. So basically we need to dramatically improve the data coverage, both temporally and spatially. And we will focus our data acquisition to the finally selected parameters in the near future. And we hope that by participating in the GEMI process, we can increase the data availability through an increased data reporting from the countries worldwide. It remains to be seen to which extent we can actually extend or include also groundwater bodies in that index. This is something we haven't really started yet working on. Another requirement coming from the international community is the inclusion of the human health relevant parameters, for example, fecal coliform bacteria. And there's a urgent need when covering aquatic ecosystems for relevant aquatic ecosystem guidelines that take into account the best attainable conditions in a water body, because at the moment every water body is handled to be the same, and the physiogeographic conditions around these water bodies in the catchments are not really taken into account. At the moment, some international water quality guidelines for ecosystems are being developed that will provide a methodology to attain such guideline values in the future, and we hope to be able to reuse these ones for the further development of the index. And finally, we need to have consistent hydrographic metadata at the global scale to assess actually the percentage of the receiving water bodies with respect to ambient water quality, not presenting risk to the environment or human health. Okay, that's it from my side. Thank you very much. And
thank you very much. So,
Thank you, Philipp. Well, I guess we have time for just one question. Yeah.
You have a question.
I didn't notice that turbidity was included. Isn't turbidity important for ecosystems?
He's asking, do you have a turbidity data? Is it in the GEMStat?
if we have what?
Turbidity data.
Turbidity, yeah. Turbidity is available. But the coverage, the spatial and temporal coverage, is not really enough to have a broad focus, cover a broad range of countries at the moment.
Okay.
Okay, thank you. Another question.
I want to ask you.
Philipp, just a quick question. What are the indicators to be used to measure the target 6.3 under the GEMI initiative?
Did you hear?
It was something with GEMI, yeah?
Yeah. Are you asking country?
What are the indicators to be used to measure target 6.3 under GEMI?
Yeah, the indicator. She's asking for the indicator. What kind of indicator are you asking for the GEMI? And what kind of target country? Can you explain about the GEMI?
The GEMI, for the second half of the year, GEMI is preparing a proof of concept in pilot countries. And at the moment, 7 pilot countries, didn't really understood the answer well, but at the moment, 7 pilot countries shall participate in that proof of concept phase. And we will test actually the implementation and calculation of further development of the indicators in these countries first. And then in a second phase in 2016 and 17, we'll try to cover as many countries as possible.
Philip, the questions about the guidelines and the indicators for the GEMI.
Which guidelines?
GEMI guidelines.
The guidelines that GEMI is using to develop indicators of water quality, which is the reference?
Well, that's still open for discussion. Actually, for water quality, at the moment, we're looking at the ones I just presented. So at the moment, it's the WHO guidelines. And as soon as the international water quality guidelines for ecosystems are finished, we will also have a look at these ones. And for the next couple of weeks, we will actually try to come up with to compile the monitoring methodology. So we will have a very intensive write-up phase in the next upcoming 8 weeks. And once that is done, you can actually have a better insight in, because at the moment, I don't know.
Okay. Thank you, Philip.
Thank you, Philip.
I need to run.
Okay, me too.
Thank you very much.
Okay, thank you.
Bye-bye.
Thank you very much.
Thank you.
Bye-bye, thank you.
Thank you. Okay.